Welcome again to Let's Talk Chemistry with Pastor Dan. We're looking today at gas laws. Now, before we do that, let's make sure we go back and review something. Back when we talked about molar volume, we talked about STP. We stand for standard pressure and temperature, standard temperature and pressure. Standard pressure, these are the different options that exist for standard pressure. 1 atmosphere, 101.3 kPas, which stand for kilopascals. 1,000 millibars, 1.013 bars, 760 millimeters mercury, and 760 torr. So on a test, when the test comes, what I'll do is I'll give it a two-part test. The first half, you'll go through and do matching and make sure you know the terms. But when you do the math itself, I'll give you those values so you're not stressing out. Standard temperature is 0 degrees Celsius, which is 273. So when we go through this, we're always going to convert to Kelvin. We don't leave it in Celsius. Why? Well, 0 degrees Celsius is undefined, and if we divide by 0. So we want to have a number that we can work with. So whenever we go for Celsius, always, always, always convert to Kelvin. All right, so let's do a little bit of that conversions. So here's all my equalities. If I'm doing 1.0455 atmospheres and I want to go to millimeters of mercury, my fraction is going to be 760 millimeters of an atmosphere. The reason for that is these are the only two that I need to worry about. So that's my equality. Atmosphere is going to go on the bottom, 760 on top. Atmospheres will cross out, will be in millimeters of mercury. Now for sig figs, I have 5 right there. I have infinite and infinite right there. So least number is going to be 5. Grab your calculator. Do 1.0455 times 760. Then we don't need a divide by 1. It's the same number. To 5 sig figs, we should get 794.58 millimeters of mercury. Let's do the next one. Okay, so if we're going to be in kilopascals and millimeters of mercury, so I want to use these two. So millimeters of mercury is going to go on the bottom, and millimeters are on top and kilopascals on the bottom. So my kilopascals cross out. Grab your calculator again. 113.98 times 760. Hit equal, divide by 101.3. 5 sig figs again, and both of these are equality, infinitely significant. You should get, plug it in, should get 855.13. All right, for the last one here. Now, there's two ways we can do it. We can do the math, which again, for 760 torr and 760 millimeters mercury would be 760 over 760. But if you think about it, it's the same number. You're just going to change the units because a millimeter of mercury and a torr are the same thing. They're just a different way of expressing it. Now, we're going to go from Celsius to Kelvin. We're going to add 273, but we can be specific. We're going to be 273.00. That way, last filled column, addition, sig figs, answer is going to be 306.98 Kelvin. All right, so let's go to the gas laws. The first one, Boyle's law. Boyle's law says for a gas at constant temperature. So the temperature is not changing. So way to keep this straight in your head, Boyle's law never boils. Has nothing to do with temperature. The volumes are proportional. What that means is one goes up, the other goes down. So pressure increases, volume decreases. Volume increases, pressure decreases. The equality here, the expression we're going to use, P1 V1 is P2 V2. So let's try a problem. So find the volume of gas container at 1.256 atmospheres. If it has a volume of 12.9 when the pressure is 0.8976 atmospheres at constant pressure. Constant pressure, telling us Boyle law. Now, the way to look for this, I'm always going to give you the preposition if, when, or where, or for, or as, one of those. So that divides it. So if I do that, my pressure is before the if, 1.256 atmosphere. My volume before the if is unknown, it's my question mark. After the if, the pressure is 0.8976 atmospheres, and the temperature 12.98 liters. Alrighty, so let's take our equation again. P1, V1, P2, V2, and we're solving for V1. So this is multiplication. The opposite operation is division, so it's going to go across and go down. Or think of it this way, if that's a fraction, volume is in the numerator, because the opposite side is going to be the denominator. So we're going to end up with P2, V2 over P1. Put our numbers in. We get 0.8976 atmospheres times 12.98 liters divided by 1.256 atmospheres. Grab your calculator, do your synthesis, do your math. Now, before we do the answer, let's look at what's happening here. My pressure is increasing. According to Boyle's law, pressure increases, volume decreases. Should be less than 12.98 liters. Check your work. I get, same I'm right, 9.276 liters. All right, it did decrease. That's our first gas law. Our second gas law is Charles' law. Now, Charles, a Frenchman. Boyle was an Irishman. Charles is a Frenchman. For a gas at constant pressure. Now, the pressure is not going to change. Volume is directly proportional to the temperature. So as one goes up, the other one goes up. Think about a balloon. You take a balloon like a helium balloon and you hold it on all night. At night, the balloon shrinks because as temperature decreases, volume decreases. I've also got a little propane tank here. If you've ever cooked with a propane tank, as you use that volume of gas inside there, it decreases, the temperature decreases, and you'll see condensation on there. That's a sign of Charles' law. Our equation here, V1 over T1 is V2 over T2. So let's try a problem here. Calculate the volume of gas at 35.8 if, that if again is my divider, if the volume at standard temperature is 15.89 liters. So let's go through here. If volume is unknown, temperature 35.8 degrees Celsius, after it, standard temperature is 0 for 15.89. Remember, standard temperature is 0 degrees Celsius. But we don't like Celsius, remember? So we're going to add 273 to both of those. So 35.8 becomes 308.8, and 273 becomes 273. All right, so let's take our equation. V1 over T1, V2 over T1. We're looking for V1. T1's on the bottom, so we're going to multiply it up or put it in the numerator. So our equation is going to be V2 T1 over T2. Put our numbers in there. 15.89 liters times 308.8 Kelvin divided by 273. Looking at our temperatures increasing, so the volume should increase. So it should be greater than 15.89. We multiply through, we get 17.97 liters. That's correct. So we did Boyle's law, Irishman first. We did Charles' law, Gay-Lussac's law, Charles' law, Frenchman. That's our second one. Our third gas law is called Gay-Lussac's law, another Frenchman. So at constant volume. So now we're not going to change the volume. Pressure and temperature directly proportional. Pressure goes up, temperature goes up, pressure goes down, temperature goes down. On a bike pump, you're sitting there pumping the bike pump. If you ever felt the size, it starts getting hot because the pressure is increasing. All right, so let's look at the problem. Determine the pressure of gas at standard temperature. If at 22.7, if again is my divider, so that's my divider there. If at 22.75 the pressure is 733.5 torr when the volume is constant. All righty, so here's our equation for Gay-Lussac's. P1 over T1 is P2 over T2. Let's start going through pressure. Before the if, pressure is unknown. My temperature says standard temperature. Standard is 0 degrees Celsius, but we want to convert that to Kelvin. We don't like Celsius, add 273. All right, after the if, the pressure is 733.5, and the temperature is 22.78, but again, we don't like Celsius. We want Kelvin, add 273, should get 295.78. Now, looking for P1. T1's on the bottom, goes the opposite side on top, so it's going to go from the denominator to the numerator. Was divided, going the opposite side, it's going to be multiplied. So my equation is going to be P1 is P2 T1 over T2. Put our values in. So 755.55 torr times 273 divide by 295.78. So hit equal. Look at our values. Our temperature is decreasing, so our pressure should decrease, and our Kelvins toss out, so it should be in torr. Take your handy dandy Joe Dandy calculator. Do your gazinthesis, 733.55 times 273, hit equal, divide by 295.78, sig figs, 273 is a constant, so therefore it's infinitely significant. So 5 sig figs, check your answer, should get 677.05 torr. All right, now, got two problems for you to work on. The first one says, determine the volume of gas at 1.06 atmospheres when the volume is 18.99 liters for pressure of, remember, when is going to be in preposition here. So volume is unknown. With that pressure, volume, pressure, temperature constant. That's Boyle's law. That's P1, V1, P2, V2. The second one, find the volume of gas at 50.98 degrees Celsius. If, there's my divider, the pressure is constant, so constant pressure, that's Charles' law, V1 T1 equals V2 T2. And then we have the rest of it. Okay, so stop the video, try it, and then once you're done, start it back up and we'll take a look. Okay, ready? Here we go for the first one. We're going to end up with our values there. So P1, V1, P2, V2, P2 over V2, P2 times V2 over P1, 2.099 atmospheres times 18.99 liters, divided by 1.065 atmospheres. Atmospheres cross out, we're in liter. Pressure decreased, so volume should increase, and my volume did increase. Very good. And then for the second one there, all right, for this one, V1 over T1, V2 over T2, temperature increases, so my volume should increase, and it did. There we go. Hopefully that wasn't too bad. Take care. God bless.